So if you stuck it out through the 3-2 section video, good for you. I know that was a long one, but I really feel like if you will stick it out through these videos, you're going to understand the Math Excel assignments, and you're going to get a lot more out of them if you will come to class, which is what you're doing right now. Okay, so 3-3, I promise you, will not be nearly as long and drawn out. We have properties of logarithms. Again, this is going to be familiar from Algebra 2. We're going to talk about the product rule, the quotient rule, the power rule. We're going to talk about expanding and condensing logarithmic expressions and using change of base property. And we're going to knock this off. I'm going to make my goal for this one less than 10 minutes. All right, so properties for expanding logarithmic expressions. Using the product rule. Let me remind you about what the product rule is. Okay, the product rule for logs says that if you have the log of a product, meaning m times n is inside the log, then that can be expanded, meaning we're going to write it using multiple logs. We're going to bust up what's inside the log. We can write that as the log of m plus the log of n. I've been leaving out the base b, but whatever base is here is the same base that you carry through. Okay, so with the product rule, we add between the logs. What do you think we do with the quotient rule? Quotient rule is the log of m divided by n inside the log. And so with the quotient rule, it's linked with the product rule. We subtract between the logs. Okay? One word of note. With the product rule, if you reverse your order and you do the log of n plus the log of m instead of m and then n, addition is commutative, meaning we can change the order. And so your answer won't be affected with Rule 1, the product rule. But with the quotient rule, you have to make sure that it's the log of the numerator minus the log of the denominator, or your answer will not be correct. Using the power rule. The power rule is where we have a power inside the log. So if I were going to put parentheses in here, I might put a parenthesis, it's giant, might put a parenthesis here, and then here. Could be here, could be there, but this P is inside the log either way. I'm going to put it here just so you see that it's inside that log. All right, so when you want to expand the log of m to the P, then what you're going to do is write it as P times the log of m. Again, still with that base of b. That's your power rule. Okay. Going from left to right, we have expanded these logarithmic expressions. Okay, let's do a couple of examples. And these are examples that are going to take 2 or more steps. Okay, so A, this is example 4. I've skipped, obviously, examples 1 through 3. You can check those out in the book. They're pretty low-level examples. But here, if we're going to expand this, okay, we have more than one property going on here. I want you to think about what's the big idea. Yeah, we have a square, but not everything's squared. And yes, we have a square root, but not everything is square rooted. Basically, the big idea is we're taking x squared times the square root of y. So the first thing we're going to have to do is we're going to use the product rule to break these up. Okay? And what you're going to see that the solution also did, I'm going to skip to here because this is what I just said. They rewrote right off the bat the square root of y as y to the 1/2 power. That's just a rewrite. We haven't expanded anything, but there's a reason they've done it, and you'll see that next. So rewrote the square root of y as y to the 1/2 power, and then expanded partially by adding between the 2 separate pieces, the log of x squared. Wherever you would say times, that's where you say plus the log of y to the 1/2. Now we need to expand using the power rule because we have an x to the second and a y to the 1/2. So we bring the 2 down in front and the 1/2 down in front. So 2 times the log of x base b plus 1/2 times the log of y base b is the expanded form for part A. We want to look at part B. This one, again, we're going to have a rewrite to begin with. Instead of saying the cube root of x, we've written that as x to the 1/3 power. And again, you need to think about what's the biggest thing that's going on in here. We have a 1/3 power, but not everything is to the 1/3 power. We have a 4th power, but not everything's to the 4th power. We have a multiply, but only the 36 and the y to the 4th are multiplied. The thing that's going on through the whole problem is this division. We have a big quotient here. And just thinking about these properties, I'm thinking forward next year to calculus. It's really important that you can understand that the quotient is the big idea here, and the exponents and the other multiply play a part, but the quotient is the big idea. Okay, so the first thing we're going to do is use the quotient rule. Expand this log partially with subtraction. Okay, I want you to notice they've grouped this 36y to the 4th to make sure you understand that it is clear that both of those are inside that log. Okay, now this next thing that we're going to do is we're not worrying about the powers yet. You totally could. But recognizing that within this second log we have a product. And so splitting that up with the plus. I want you to notice the parentheses. The parentheses that are here and here. It's gonna fix it. Anyway, you see the parentheses I'm talking about. You have to have those, because if you don't, then you will not be distributing the negative into that group. Okay, so if you're going to expand this product at this point, you need to put the parentheses in there so you can say, I'm subtracting the log of 36 and I'm subtracting the log of y to the 4th. Okay. At this point, we've started dealing with some of those exponents. Brought the 1/3 down, power property, brought the 4 down, power property. And now carrying the negative through to both of those. The last thing you're going to notice here is that all of a sudden we have gone from a log of 36 base 6 to a 2. Okay? Gone from a log of 36 base 6 to just a plain old 2. I want you to remember our properties from lesson 2. The log of 36 base 6. 36 can be rewritten as 6 squared. And so the log of 6 to the 2nd power, base 6, is going to be 2. Okay, we can rewrite that 36. You might need to write that out just to really understand what's going on. But here is some explanation to the side. It has to do with rewriting 36 as 6 squared. Okay, with that, you can do the first 8 questions in your Math Excel assignment. So you can pause now and go there. I don't know if I'm going to make my 10 minutes, but I'm certainly going to try. Whew. Condensing logarithmic expressions is next. And I just want you to see that you don't have anything new to memorize. Condensing, we have a property box in our book for expanding and a property box for condensing. And I want you to see the differences. Here's the product rule. Instead of writing it as a product and then as the sum of 2 logs, we write it as the sum of 2 logs equals a product within 1 log. They are the exact same rules. We're just going backward. We do not have to write these rules down twice. Okay, so if we're going to condense, we have to ask ourselves, instead of how can we break these apart, how can we bring them together? Okay, so if we have addition between 2 logs, we will multiply within the log, the 2 times 32 to get 64. And then again, just like we had the log of 36 base 6 before, here I've squeezed this in. We can think of 64 as 4 cubed. So the log of 4 cubed base 4 is 3. Okay, now with part B, we have the log of 4x minus 3 minus the log of x. Okay, we are subtracting between logs, so the quotient property will allow us to condense those. So what I have boxed in is our answer there. Don't know why it's doing this. Okay, sorry about that. All right, now, write as a single log. Again, we're condensing, except these are a little more tricky with the condensing, okay? So with part A, 1/2 log x plus 4 log x minus 1. We're going to work these in kind of the opposite order than we saw them earlier. We want to get this as 1 log plus 1 log. To do that, we're going to have to take care first of these multipliers that are outside of our logs. So the 1/2 and the 4 we have to take care of first. Okay, and you can see that right there. It's the log of x to the 1/2 plus the log of x minus 1, all of that to the 4th power. At that point, then, we can take care of this plus in the middle and bring those together with the product rule. You could write x to the 1/2 power as the square root of x. You can see that alternate answer right there. Part B, again, you look at this, you take care of the 3 first to make it the natural log of x plus 7 cubed minus the natural log of x, and then the subtraction between makes this a quotient within the log. As for the last one, I love this one. I should tell you something for your quiz, that I like this kind of problem in particular. I lost my 10 minutes, I know. We're going to take the powers and we're going to bring those up just like we've done. But now we have this double subtraction. And if you have 2 subtractions, it really just means that we're dividing twice. I'm going to totally skip. If I were doing this problem, I'm going to show you how I would do it. Okay, I would skip from here, I would skip down to there. Okay, if you can think about it like this, we're going to take x to the 4th and we have to divide by 6 squared, or 36, and we have to divide by y to the 1/2. So here's x to the 4th divided by 36 and by y to the 1/2. I would not go to the trouble of doing these middle 2 steps. Okay, if you understand them, if they make sense to you, that's fine, but it's more work than you need to have. Okay, you're now ready for Math Excel numbers 9 to 14, if you want to pause and do those. Last thing, real quick, change of base property. Remember, your calculator will only calculate a log base 10 or a natural log, which is a log base e. So if you have any other base, your calculator is not going to be of help to you unless you use the change of base property. The change of base property says that you can calculate the log of m, base b, if you take the common log, remember that means base 10 log of m, and divide by base 10 log of your base. Okay, so the log of m base b is the log of m divided by the log of b. You can also use the natural logarithms within the change of base property. You could say the log of m base b is the natural log of m divided by the natural log of b. I tend to go with the natural logs because ln is 2 characters and log is 3. I mean, that's the best explanation I have for you about how I choose. That should tell you that it really doesn't matter. Last 2 examples, and I'm cutting you loose with the rest of the assignment. Changing base to common logs, changing base to natural logs. I want us to follow through examples 7 and 8 together because they're really the same problem. We start off with the log of 140 base 5, but over here we're supposed to use common logs. And in example 8, we're supposed to use natural logs. So if we follow that, the log of m base b is the log of m over the log of b, or the natural log of m over the natural log of b. We're going to be doing the log of 140 divided by the log of 5, or the natural log of 140 divided by the natural log of 5. Either way, we get 3.07 approximately. One thing I want to caution you about, make sure that you're closing your parenthesis after the 140. If your calculator opened a parenthesis when you press log or natural log, make sure you close it after you do the 140, after your numerator. Okay, so you're now ready for Math Excel, numbers 15 and 16 specifically, and then 17 is an application problem.